Hello and welcome to our new unit on area. In this particular lesson, we're going to cover area of our quadrilaterals, well, some of them, and our triangle. Pretty much all triangles, but we're going to start with parallelograms, rectangles, rhombi, squares. Area, let's start with defining what area is. Area is let's do black. The amount of square units a geometric figure encloses. So geometric figure is just a closed figure. Encloses. So for instance, if we have like a triangle, we could calculate the number of square units it has inside of it, or a rectangle, a rhombus, a pentagon, a pentadecagon, a decagon, a nonagon, or even a circle. We could calculate the number of square units or the amount of squares that actually fit inside of it. And we're going to go over all these examples. And if you notice, we're actually starting off with a rectangle as opposed to a parallelogram. Why a rectangle? And it's because we could actually, when you have 90-degree angles, it's actually easy to calculate the number of squares that actually fit inside of it. So if you're looking at this rectangle, for instance, we could literally count, okay, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares inside of it. Thus, this will be 12 units squared, and this unit of measurement, as you can see here on the far left, is in inches because 1 square is an inch. This would be 12 squared inches or inches squared. Now, there's an easier way to calculate area, and that is if you have the length and the width, or in this particular case, we're going to be using base and height for all of our formulas. So we're actually going to say area of a rectangle is equal to base times the height. Simple enough. We're going to call 4 inches the base, and we're going to call 3 inches the full length of the width. We're going to call this the height. So get used to using these instead. And we could actually calculate this. Area is equal to 4 inches times 3 inches. Now, why am I putting the units of measurement in there? It's because when you actually multiply, you're going to see why. 4 times 3 is 12. Inches times inches, we don't actually really multiply anything numerically there, but inches squared. That's where the inches squared is. It is a unit times a unit, which is unit squared. So as we predicted, the area of this rectangle is 12 inches squared. Here, rectangle follows the same rules. You could literally count the number of squares inside of it. It's a 3 by 3, making it 9 square units. In this particular case, we're using feet. So we could say area is equal to base times height again. Or we could even go fancier and say area is equal to side squared because the side lengths are congruent. The base is congruent to the height. So I'm going to lift this up just to make this a little neater. Area is equal to base times height. So if you remember your rectangle, you should be able to do the square as well. So area is equal to 3 feet times 3 feet. Notice that I'm not using the feet in the equation this time. I'm just going to tack it on at the end. 3 times 3 is 9. We know this is feet, so this should be feet squared. Okay, so rectangle, square, simple enough, base times height. Parallelogram is slightly different. It's a different shape altogether because it is slanted now. So this is a little trickier to understand, but if we use the rectangle as a foundation for area, we could actually convert this parallelogram into a rectangle. If you don't believe me, I'm going to pretend to cut this away. I'm going to do this in pink. Here we have a parallelogram because opposite sides are congruent. So I'm going to cut this out. I'm going to chop this off of the quadrilateral, and I'm going to shift this over. So, let's do this to make this a little visually understandable. I'm going to shift this. Actually, it would have been better if I did this. Here, let's do this. Let's do that all in one piece. So I'm going to cut this out. okay? And what happens when I cut this piece out? And I shift this all the way over to the right side. Well, this shape now, so if we pretend that that is gone, this is chopped away, this is all gone. What shape this is now a, in blue, rectangle. It still has the same, ooh, that's not what I wanted to do. This is a rectangle now. It still has a base of the 2 tick markers, 4 units. It has, we don't know what the height is, but we do have a side length here, and we would need a little bit more information to complete this problem. So as you can see, this parallelogram can turn into a rectangle if we really, really try. So I'm going to make this a little bit easy. I'm going to put values here so we can actually calculate this. I'm going to put, for instance, let's keep this as red. If I said the height of this was 8, and the full base of this is, let's say, 20. Let's say, yeah, just go with 20. That means we have a height of 8 and a base of 20. Areas would still technically be equal to base times height because we could turn this into a rectangle. And we could calculate this. Now, notice this time, there are no units of measurement. So we could do 20 times 8. So area would be equal to 160, but there's no unit there, so we actually just say units squared. And we are done, okay? So that's how you would calculate a parallelogram. You would need the height to actually solve for it. So, area of a rhombus follows the exact same rules because a rhombus is technically a parallelogram. The difference is all the sides are congruent. Okay, so for the sake of it, let's say that this one side had a length of 5. Let's go with 10, actually. 10 would be a little bit easier. And that means this had a length of 10. This had a length of 10. Let's call these inches. Or let's go centimeters. Let's be a little different. Centimeters, centimeters, centimeters. All sides in a rhombus are congruent. And to make this a little more challenging, let's pretend that this distance here is equal to 6 centimeters. Okay, obviously this is not drawn to scale because this is 1 square as opposed to 3. It wouldn't make sense for this to be 4. So this is not drawn to scale. So don't take it, literally. We need to calculate the height of this rhombus. And we could do that because didn't we just make a triangle? And don't we know that if you have 2 out of the 3 sides of a triangle, of a right triangle, you could use the Pythagorean theorem to solve. So we have a right triangle here. So I'm going to do this here off on the side. Here's your right triangle that we just formulated. We have a right angle here. We have a hypotenuse of 10. We have one leg that's 6. And hopefully remember, we have our 6, 8, 10. Pythagorean triples will come back in a big way. We have our 8 here. So we know that this height is equal to 8 centimeters. And now we could actually solve for this. So area is equal to base times height still. That's ultimately what I want you to take away. But we could actually use what we know about right triangles to solve for height as needed. So area is equal to base of 10 centimeters times 8 centimeters. Area would then be equal to 80 centimeters squared. Okay, so we can break this down further if needed. The last thing we're going to cover is a triangle. But if you notice, I put a rectangle here. That's kind of strange. Why would I do that? Well, because if you really think about it, a triangle is literally just a rectangle that is cut from diagonal to diagonal. If you remembered any of our rectangle problems, this is what we did. If we need to solve for the diagonal, we could. And a rectangle in red or in black is now cut into 2 different triangles, one in red and one in black. So how do you find the area of a triangle? Well, you literally just cut a rectangle in half. What's the area of a rectangle? Area is equal to base times height. But since we're cutting it in half, we're going to put a 1/2 in front of this. And here's your area of a rectangle. I'm going to erase the rectangle now, and there's your area equation. So no matter what the piece is, we could kind of revert it back to a rectangle so we could measure it in square units. So if, for instance, we had 3 units here and 4 units here, just like the original problem up above, the very, very first one, we could say that the area of this triangle is equal to 3 times 4, which is equal to 1/2 times 3 times 4, which is equal to 6. 6 units. Ooh, that's a terrible end. 6 units squared. And we are done. All right, so only 2 equations that we covered, which is great. It covers a lot of information. Base times height is your foundation for rectangles, squares, parallelograms, and rhombi. And then technically, it is a version of a triangle as well. If you do have any questions, please ask, and I'll see you in the next one. Bye.